Hey everyone. So today we're going to talk about some of those elements that we have avoided up to this point. These little transition elements or transition metals, the ones in the center, and some of these along the side as well. So we've avoided these because they don't really act a lot like the other elements do, the main group elements. The main group elements are the ones that we've talked about so far that have those nice, easy to predict patterns. So everything in group 1 has a charge of +1, group 2 has a charge of +2, group 3 has a charge of +3, and then in group 4 we have that switch. So we can have either positive or -4 here. Group 5 is -3, 6 is -2, and 7 is -1. And of course, our last column here, our last group, these are noble gases, and they have 0 charge because they're already full, and so they don't need to do any work to try and get electrons, they've retired. And so all of those charges are based on how many electrons they need to give away or that they need to take in order to complete their valence shells. If you're not sure about that, then just watch the previous video that was on Lewis dot diagrams and bonding. So today, talking about those, we've got 2 ways of looking at different compounds. So one, we can go from the name. So let's say that we have something that says copper 1 bromide. And we can tell from this name here that the charge on copper is going to be 1. So we always use Roman numerals to indicate what the charge is going to be on our metals. So again, keep this in mind. A lot of people get confused. This is not about how many coppers we have. This is just the charge of that copper. So if we're going to be writing this out, we do what we would normally do, where we'd put our symbol, and then we'd have our charge. We'd put the non-metal symbol, put the charge down there as well, and then do that cross down to figure out how many of each of these we need. And for that copper, we just need 1 copper or 1 bromine. So going from the name to the formula isn't much different than what we had before. We just have to remember that this tells us what the charge of that metal is going to be. It's a little bit tougher at times when we're going from the formula to the charge, or to the name. So let's take into account 2 different examples. One, we have copper 2 and carbon, and here we've got a copper with a 4 beside it and carbon. Now if you remember where these numbers come from in the first place, these numbers are what were brought down from the charges of each of these elements when we did that cross down. And so we can actually work backwards and actually do a bit of a cross up to go from the number of atoms to charges. So just a little bit of a refresher. You can move when you have the charges and you're given the name, you put down the charges and then you cross down to figure out how many there are. We are doing the opposite here. We're starting with how many there are and then we're crossing backwards to find out the charge. So this 2 here is going to go up to carbon. And now there's no number written there, and those are our 1s. That 1 we're going to move up to copper. So we can't just say that the charge of copper is going to be 1 because this is a ratio. So that means that for every 1 carbon we have, we're going to need 2 coppers. And so we know that this is some kind of ratio. I'm going to put a positive there because this is a metal and our metals are positive. But I'm going to put a little X here because we might have to multiply copper by something in order to figure out what the real charge is. In the same way, we have our carbon, and I'm going to put a negative here because carbon is a nonmetal, and nonmetals are negative here. And I know it's going to be 2, but it's going to be 2 times something. So I know I'm going to have 2 times the amount of coppers for each carbon, and that means that the charge of carbon's going to be 2 times more than that of copper. Okay? So step 1 is us doing that backwards step to be able to move up the charges and figure out what the charge is based on how many we're given. Step 2 is to try and figure out what is that X. So here, I may not necessarily know the charge of carbon, of copper, but I know the charge of carbon. So the metal might change, but the non-metal does not. So I can look at, I know that carbon, whatever it is, times 2 is going to equal -4, because carbon here is in the 4th column. And I know that carbon's going to be a negative because it's paired with something that's positive, and these ones are always going to be opposite charges. So carbon, whatever that -2 is going to be multiplied by something to give us -4. And then my third step is just me trying to solve for that x. Okay? I'm going to put an x there by copper because it's the same thing. So I'm going to have to, I can see already that I'm going to have to multiply this by 2 in order to get 4. So -2 times 2 gives us 4. So that means that that little x is actually a 2. I've got to do the same thing over here with copper and change that little x into a 2 as well. And then I'm just going to finish off by figuring out my charges, and this copper is going to be a charge of +2. And this carbon is going to be a charge of -4, which is the thing that we got from the periodic table. Now for naming this, I always write the metal first. And because this is something that can have more than one charge, I'm going to put those brackets there and then put that number, those 2 lines in there for the Roman numerals for 2. I'm going to write my non-metal last, and I take off the ending of carbon, right where the vowel is, towards the end. And with all compounds, I'm going to end that "-ide". So that "-ide" is showing me that this is actually part of a compound. So that is us looking at what happens when we have 2 coppers to every 1 carbon. The other situation we might have is that we might actually have 4 coppers for every 1 carbon. And I'm going to do the same steps that I did before. So first, I'm going to move these these numbers back up so I can have an idea of what the charges are. So that means my copper is going to be 1, still positive, so it's 1x, because this 1 moves up here. And my carbon is going to be, still negative, it's going to be 4x. Okay, so that 4 moved back up here. Again, this could be just a lowest ratio, so I want to make sure that I have this down as an x, so I'm not making an assumption on the charge. My second step is going to be trying to figure out what that x is. So here I know I can't really do anything yet with my copper, but I know that with my carbon, whatever this is going to have to equal 4. And so I've got to solve for x in this situation. And so in order to solve for x, I know that I'm going to have to multiply -4 by a 1, or just keep it by itself, in order to get -4. So I don't really have to do too much here because this x is actually just going to be a 1. But I'm going to plug it in here anyway, just because it's good to get into some habits. So I'm going to multiply my +1 here with copper by 1, and my -4 here with carbon by 1. And our last step is just to kind of finish that off and simplify. Here the charge of copper is +1, and here the charge of carbon is -4. So if we're going to be writing this out, I'm going to do the same thing that I did in the other one, but in these brackets here, I'm going to put a 1 because the charge of this is 1. And the naming rule still applies, so we're going to add that "-ide" there just to show that it is a compound. So this one's a little bit tough. This is probably one of the tougher ones that you'll see, but just remember that these numbers at the bottom come from the charges. So just in the way that you can move from charge to how many atoms there are, you can move from how many atoms there are to charge. You just got to move across to the other element.